In this episode, we're going to connect metadata access to the bigger outcome attackers often want, which is privilege escalation across cloud workloads. Privilege escalation sounds like a dramatic term, but at its core it simply means gaining more power than you started with, often by moving from a small foothold to broader control over resources and identities. Metadata becomes part of this story because it can hand out tokens that represent a workload identity, and that identity might have permissions that reach far beyond the single instance that was initially compromised. Once an attacker has a token, the attacker can often start operating in the cloud control plane, listing resources, reading data, and sometimes modifying the environment in ways that create even more access. Our goal is to help you detect the early signs of this chain and understand prevention strategies that break it in multiple places. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start by picturing the typical starting point: a single compromised workload, such as an application server, a background worker, or a small service that processes requests. The compromise might come from a software flaw, a misconfiguration, or a supply chain issue. But the important part is that the attacker can now influence what happens inside the workload. At that moment, the attacker is not automatically a cloud administrator, but the workload might be. Many workloads are given a service identity so they can access storage, read configuration, publish messages, or call other services. That service identity often uses metadata to retrieve temporary tokens, and those tokens are what allow cloud API calls. When the attacker steals that token through metadata access, the attacker is effectively wearing the workload's badge, and the badge can open doors. Metadata-driven privilege escalation across workloads often follows a pattern that is surprisingly consistent. First, the attacker queries metadata and obtains a token tied to the workload identity. Second, the attacker uses that token to call cloud APIs to discover what resources exist and what permissions are available. Third, the attacker looks for permissions that allow them to change identity relationships, such as attaching more privileges to the current identity, assuming a more powerful role, or creating new identities. Fourth, the attacker uses those new privileges to access additional workloads, additional data stores, or management capabilities, expanding the blast radius. The escalation is not always instant, but it is often fast because cloud APIs enable rapid exploration. The calm way to understand this is to see it as a step-by-step expansion of authorization, not a mysterious magic trick. One common escalation path is permission expansion on the same identity, where the attacker uses existing permissions to grant themselves more power. For example, if the workload identity can modify access policies, attach roles, or update permissions on resources, then the attacker can often increase their own ability to read or change things. This kind of escalation is especially dangerous because it can be hard to detect if you are not watching for policy changes. In many organizations, policy management is treated as a normal operational task, so changes can blend in if there is no strong change control and alerting. The prevention lesson is that identities used by workloads should rarely have permissions that allow them to grant themselves additional permissions. If a workload can change its own authority, it becomes a platform for escalation when compromised. Another common escalation path is role chaining, where one identity can assume another identity, and the attacker uses that capability to climb the ladder. Workload identities are sometimes given the ability to assume different roles for different tasks, which can be a clean design when done carefully. The risk is that role assumption can become too broad, allowing a workload identity to assume roles that are more powerful than needed or roles that exist in other environments. If an attacker can assume a stronger role, the attacker now has a new token with a new permission set, and the escalation is complete. Prevention here means controlling who can assume what, under which conditions, and ensuring that role assumption paths are narrow and purpose-driven. A COM examiner will look for the question's clues about overly broad role assumption and treat them as potential escalation triggers. A third escalation path involves access to secret stores or configuration that contains higher privilege credentials. Some environments store privileged tokens, keys, or administrative connection strings in centralized secret systems, and workloads retrieve them to perform tasks. If a compromised workload can access those secrets, then metadata token theft becomes a stepping stone to stealing even more valuable credentials. Even if the secret store is well designed, the workload's permissions determine whether the workload can retrieve sensitive items. If the workload identity can read large sets of secrets or can read secrets meant for administrators, then a compromise turns into privilege escalation quickly. Prevention here is straightforward in concept. Restrict secret access tightly, separate secrets by environment and purpose, and avoid giving general workloads the ability to read everything. Detection involves monitoring secret access patterns, especially sudden spikes or access from unusual workloads. Now shift from escalation mechanics to detection, because detecting early is often what separates a small incident from a major breach. Detection starts with knowing what normal looks like for a workload identity. Most workloads perform a limited set of cloud actions repeatedly, such as reading specific storage paths, writing logs, or pulling messages. When a workload identity suddenly starts listing many resources, querying identity services, or modifying policies, that is often a sign of exploration, which attackers do early in an escalation chain. A key detection idea is that attackers need to discover what they can do, so they often call APIs that enumerate resources and permissions. If you can detect that discovery behavior, you can intervene before the attacker reaches their highest privilege goal. This is why cloud audit logs and identity activity monitoring are so central to cloud security outcomes. Metadata-specific detection can also matter, even though it is not always treated as a first-class signal by beginners. If a workload suddenly makes unusual requests to the metadata endpoint, especially in patterns that match token retrieval, that can indicate an attempt to harvest credentials. In some cases, compromised code will query metadata repeatedly to maintain fresh tokens or to gather environment details. Even if you cannot directly monitor metadata traffic easily in every environment, you can often see the downstream effect. New tokens being used, new API calls appearing, and new access patterns emerging. The key is to connect the idea of metadata access to observable cloud actions, because attackers do not steal tokens as trophies, they steal them to use them. If you see a workload identity making unusual management calls, consider metadata-driven token compromise as a likely source. Prevention is strongest when it breaks the chain in more than one place, because single controls can fail. The first breakpoint is stopping metadata harvesting, which includes restricting metadata access, requiring special request properties, and blocking request forgery paths in applications. The second breakpoint is limiting workload permissions so that even a stolen token cannot do much, which is least privilege in practice. The third breakpoint is limiting identity relationships, such as narrowing which roles can be assumed and restricting permissions to modify access policies. The fourth breakpoint is protecting secrets and privileged credentials so a compromised workload cannot simply retrieve administrator-level access. When these layers work together, an attacker may still compromise a workload, but escalation becomes slow, noisy, and limited in impact. That shift is the practical definition of resilience. Segmentation across workloads is also a prevention strategy, because escalation often involves moving laterally from one workload to another. If workloads share networks freely, share credentials, or share broad access to common resources, an attacker's path becomes easy. If workloads are isolated by network boundaries, by distinct identities, and by resource-level permissions, then compromise stays contained. Beginners sometimes think segmentation is only a network concept, but in cloud it is also an identity and resource segmentation concept. Two workloads might sit in different subnets, but if they share the same powerful identity, segmentation is mostly an illusion. The best prevention patterns align network isolation with identity separation and with distinct permission scopes, so lateral movement requires crossing multiple independent boundaries. On the exam, scenarios that mention shared roles or shared identities across services should raise your suspicion. Another prevention concept is to avoid giving workloads direct ability to make privileged management changes unless there is a clear reason. Many workloads need to read and write application data, not manage cloud infrastructure. When a workload can create new instances, update network rules, or modify access policies, it becomes a tool that can reshape the environment when compromised. Sometimes those capabilities are needed, such as in automation systems, but then those systems become high-value targets that require additional protection. A COM risk assessment looks at whether privileges match purpose and whether privileged automation is isolated, monitored, and constrained. If a scenario shows a general application workload with broad infrastructure permissions, that is a red flag for metadata-driven escalation because the attacker's first token is already powerful. Prevention and detection also rely on strong change awareness because escalation often involves changes that can be captured. Adding permissions, attaching roles, modifying policies, creating new identities, or enabling new access paths are all actions that can be logged and alerted on. If your environment has clear baselines and strong alerting on high-risk changes, then an attacker's escalation path becomes more visible. Beginners sometimes assume that logging exists but do not think about alerting, and that gap matters because logs that nobody reviews do not stop escalation. A mature approach treats certain actions as inherently suspicious unless explicitly planned, such as granting administrative permissions or opening broad network access. When you treat these actions as high-signal events, you can detect escalation earlier and respond faster. As we close, metadata-driven privilege escalation across cloud workloads is a chain that starts with a local compromise and ends with broader cloud control, often through stolen tokens and overly broad permissions. Attackers love this path because it is fast, uses legitimate interfaces, and can be hard to distinguish from normal automation if you are not watching for unusual patterns. Detection depends on monitoring workload identity behavior, especially discovery actions and policy changes, and on noticing when workloads begin acting outside their normal scope. Prevention depends on blocking metadata harvesting, constraining workload permissions, restricting role assumption paths, protecting secrets, and aligning segmentation across identity and network boundaries. When you can see the escalation story as a connected sequence and you can name the breakpoints, you will be able to judge scenarios calmly and choose the answer that reduces both likelihood and impact.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.